So this video will talk about vector equations of lines, how to find the equation of a line given certain points. We'll also talk about changing from a vector equation to a Cartesian equation and vice versa. So what we're going to start with is we have this line segment where we have A, so we have the vector A from the origin and vector B from the origin to give us point B, and we also have what we call vector P to give it P. So the question is, how can we work out what P is or the vector P? So basically when we start, we know AB is a line segment between A and B. Then what we can say is AP is in fact a scalar multiple of the line segment AB. And this is pretty straightforward in that sense. So if we want to find P, we can use this kind of approach. So if we have AP, so we want to find AP, and what we're going to say is that it equals T times some AB segment. So that's kind of switching it around, I know. So when we have the vector P, it equals, well, the vector P equals the vector A plus some AP value. So we have the vector A plus AP. Now, well, what is AP? And this is what we need to get to. Well, AP is in fact a scalar multiple of AB, because that's what we established here. Okay, and then what we have is, well, vector A is equal to some scalar of the vector A plus the vector B. Sorry, vector B minus the vector A. Get them in the right order. Okay, so this helps us to find when we're given 2 points. So the example in your textbook says that find the vector equation of a line where the points A and B have position vectors. So the origin to A equals I plus j minus 2k, and the origin from origin to the B, so this one here, has the equation 2i minus j minus k. And so what we need to find is, well, it's going to ask us to find the vector equation of the line AB, and we're not sure what that is. So what we can do is we can say AB equals AO. So what we've done is in fact switch the numbers around, plus OB. Now when we switch the numbers, it's where I switch the letters around, we actually need to change the sign. So we have equals minus I plus j minus 2k. So that's the changing, we had to change the sign out here, so that's the only thing that's different. Plus 2i minus j minus k, which is equal to I minus 2j plus k. Therefore, the vector of the equation of the line is equal to R, so we're going back up to here, R is equal to OA, which is the original vector, because remember we have this equation up here, plus some scalar value of AB. So to work that out, all we do is we put in the values we have. So we have I plus j minus k plus some scalar value of I minus 2j plus k. And t has to exist in the set of reals. We can also expand that out if you want to, but that's not necessary. So there's all different things we can do using these identities. I guess they are identities in one sense. So the second thing we need to go through is a Cartesian equation of a line in 2 dimensions. So for example, we start with the vector r equals to I plus 5j plus t, because we've found out what it is, I minus 2j. So this is where we ended, so we're going to start the next bit. So this is Cartesian equation of a line. So we can rearrange this equation, and what we get, so we're going to expand everything out, so we get I plus 5j plus ti minus 2tj. Now the t's get a little bit confusing, I know, and we collect the like terms and we end up with 1 plus ti plus 5 minus 2tj. So what we can in fact say, well, we have an x value equal to 1 plus t. So this is our x value. So x equals 1 plus t. Y equals 5 minus 2t. And these are what we call the parameter equations for the line. Now to eliminate t, you have to find y in terms of x. So we have y in terms of x. So we have t equals to x plus 1. And we also have y equals to, well, this is a little more complex because of the 2. So what we can do is say y equals 5 plus 2 outside of x, sorry, 2 on the outside, x minus 1, because we've changed the signs and we're also using this equation up above, so it's like a simultaneous equation, which equals 2x plus 3. So the Cartesian equation of the line is y equals 2x plus 3. Now this is just practice. This is the hard bit to get right, I find. So often what we need to do is we need to expand, rearrange, and try and get to the answer. So we're going to start. So I guess the other way is from vector to equation. So what we're going to do is we're going to start from a Cartesian equation. Let's just start with the one we currently did, y equals 2x plus 3, because we know what the answer is. So a point on the line, we got any line, and we're going to give us 0, 3, with the position vector 3j. Now you can draw that, that's quite an easy one to draw. So a vector parallel to the line is I plus 2j, because it has a gradient of 2, so we could look at it by drawing it. So therefore, a vector equation of the line is I equals to 3j plus t, I plus 2j. So that is the Cartesian form, Cartesian equation to a vector equation. Now there are some generalized rules around this that we need to look at, and there's also a few facts. So the rule for Cartesian form an equation of a line in space passing through the points A, A1, A2 and A3. So they're kind of a point, and B, B1, B2 and B3 is this. So we have x minus A1 over B1 minus A1 equal to y minus A2 over B2 minus A2, and z equal to, z minus A3 over B3 minus A3. You cannot describe a line in 3D using a single Cartesian coordinate, and that's something to know. And so this form is called the Cartesian form. And that's important to know. So just have a look through, particularly page 174 in your textbook has a great table that I thought was really good, and it shows all the different forms.